that's about SDDC. Let us understand what are the traditional networking, the complexity. What are the problems or challenges the traditional network has? So the traditional network has like box by box operation. Am I right? You have access, you have distribution, you have core. Then you will have switches for data center. Then you have for backbone. You are running on ISP, MPLS, maybe DWDM, whatever it is. So everything is a box by box operation. Then when you want to program, then you go do telnet or SSH, start configuring IP address, OSPF, BGP, and if you do mistake, then there is a downtime. All these things. So it's kind of brittle and opaque. It's very difficult to control. So networks have become a barrier to data center modernization. When you have one side, they want to launch the application, the services very quick to the market. Another side, your network is still the old phase. So there is a big gap, big challenge. So let us talk about an analogy. And when you talk about software-defined networking, let us understand something which we use in day-to-day life. Let's start with automobile industry, right? So you know that initially the engine is not exposed to the driver because everything is inside. You only have the dashboard about the speed, the petrol, the fuel, everything he knows from the dashboard. And after that, it came intent-based training. You have steering control. You can set the limit, set 120 kilometer. You put your, auto lock, then it drives. Then you have a navigation. Am I right? You have put a map, then it guides you. Drive, brake, accelerate, everything comes more sophisticated. But what's happening now? Today, autonomous driving, driverless cars, all right? We'll pause for a few minutes as there is Adhan. Driving, am I right? Driverless cars and everything is controlled by GPS and navigation, and they're integrated with deep learning, artificial intelligence, machine learning. So that's what is the industry is moving towards. So even today we have most of the network vendors in the software-defined networking, they are integrating machine learning and artificial intelligence. So maybe after 6 months, 1 year, you'll find that how intelligent this network components have become. From the way we used to think and work in network, and the way we are going to see the network, it will be completely different. Okay, that's the direction the entire industry is moving around. Okay, the next generation DC networking, leveraging the Intel. Am I right? What do you want to do? You don't go and talk about I need to configure OSPF, I have to configure the bandwidth. No, you tell this is my intention. Okay, I want to do 1, 2, 3. Can this network do everything by itself? Imagine if that can happen, how quick you can provision services. That's something called intent-based networking. Okay. So you tell, I have a design intent. I want to deploy a SAP application. I want to deploy an Oracle application. I want to have a video conferencing across my 10 branch offices connected through MPLS. And this is my intention. And I am saying that in the intention, in the GUI, I am just coming and telling, okay, can you do that? I will just translate that in a GUI and push the policy. And there is an intelligence, which is a controller, which takes this information, pushes the configuration for the switches, firewalls, the VMs, and everything is provisioned automatically. That's the power of intent-based networking. That is the power of software-defined data center. So down the line, if you see, there won't be any work for network engineers. Honestly, that's something which is alarming, but that we need to anticipate and accept and prepare ourselves to face the challenge. We cannot say now, I'm good in OSPF, I'm good in OS, BGP, and I will continue to be that. I can only talk about it. I don't bother about what's happening in cloud, what's happening in software defined. I'm not a software engineer, so why should I care? No, that's even if you don't care, you will be forced to learn. Okay? Okay. So what's happening is previously what, and how that you start designing then how you have to have a rack, top of the rack, VMware, Dockers, everything. Then you say add a switch. But now everything is done. Once you have design done, then you say deployment I want to do, and this is implemented in the boxes across. Okay, because this boxes doesn't have any intelligence. You have a controller, and the controller pushes the policy to the boxes. So we call it as a white box. It can get programmed based on the policy which is pushed from the centralized controller. Same team can manage a lot more network infrastructure. So previously you had different teams to manage and everything. Now you just push it and use the time for other work. So legacy teach networking, feature-based, box-driven. What do you mean by feature-based? You have to have features, like I say it's a L2 networking. So you'll buy a switch, only support VLANs, right? Then you say I want L3. So you have to pay cost for license for OSPF, BGP, or if you are having some quality of service, or if you're having security feature, you buy feature sets. Your cost is based on the features. So all the boxes are feature driven. And if it is not compatible, what happens? Every year you go for network refresh. Last year you upgraded, this year Cisco will come, or Juniper will come, or XYZ will come and tell you, sorry, you have a new design, but my box, which you bought 1 year back, it's not supporting. Either you have to upgrade the firmware, which we will charge you, or you have to change this product because this product cannot run the code. How many times you have faced this? Face a lot, am I right? So this is because you have limited with the features. Am I right? So what happens when it's become intent-based? I don't care about the box. The box remains same. It's all about a capacity. The box has 10 gig, 40 gig, 100 gig capacity, and then it has a controller. It has a brain, small brain. And I have a controller. The controller instructs, push the policy so that the box can be changed based on the way you think about, or based on the intention you want the network to behave. So if that is going to happen, you don't bother about it. So only if anything has to be done, only a firmware upgrade. Am I right? Because the main feature is residing at the controller, at the brain. So that is the change which is happening. And the last one is, which is going to happen, is knowledge driven, which is autonomous, which will have even artificial intelligence, machine learning, and will be cloud native. So even it will take information from other resources and it will input to the decision. Normally now we are telling the decision, am I right? I need the application to be changed. Maybe it collects information and give the input to the brain, saying that to the controller. Now the situation has changed, so you start behaving differently. So it collects information. So it is autonomous. So that's the feature which is happening. So Big Switch is positioned that way, the next generation data center networking company. So mainly this you will not see in normal small and medium enterprises. It mainly positioned, as I said, big enterprises or ISPs. Okay. And they have DC switching as well as DC security and monitoring, where they call it network packet broker, where they can capture the entire traffic and give you the dashboard, what's happening inside the network. Maybe they can record all the calls, all the conversation, reproduce. So all those features are available. And they have different products. I'm not going to talk about it. So you have a big cloud fabric and big monitoring fabric. So cloud fabric is for SDDN, monitoring is for security and monitoring. Okay, you can monitor the entire infrastructure. And the network hyperscale infrastructure, you can have Google, Facebook, Microsoft, all of them can be working together on this platform because you have a controller software, and also it's mainly works with open networking hardware. That's what the answer what Ala has asked. How it differs from Cisco or Juniper. They are all vendor specific. But this software, you can buy the software and load it on hardware, and irrespective of any platform. You can buy from Dell, you can buy from HP or any other vendors which supports open networking platform. Okay, this open networking platform is it's something like an open standard, which everybody works together, collaborate. So it's not vendor specific. That's what is mainly taking the industry. That's why HP is adopted, Dell is adopting, and so many other vendors are adopting that concept. and also they have scale-out fabric architecture. Great. So, what is this all about for a CIO, Chief Information Officer perspective? Can the networking team play a larger role as public cloud usage matures? You have now something called on-prem, on-cloud, hybrid cloud, private cloud, all those concepts we are talking about. What is the key challenges when you are talking about cloud, especially in 2018? They talk about security. Am I right? When I put your data into the cloud, so you are worried about security because your data is on cloud. Second thing is governance and compliance. For example, country like UAE, they don't allow you to put on public cloud. So all the companies, most of the companies, they would prefer to have private cloud. And even if you want to have AWS, you want to have Azure, they say, I'm fine with that, but bring it on-prem. I want to do everything in my premise. Maybe I can have kind of a hybrid cloud for vendors, maybe integrations, but mainly I want to do it hosting here. Or use our infrastructure in Etisalat or do any other, Infosys, they have a big data centers. The government is more worried about that compliance and governance. They don't want any data to be going out of the country. So that's another challenge. Then staff lacks cloud capabilities. How many of you now, if I ask you how many of you are CCNA or Microsoft, everybody will raise the hand. If I ask you how many of AWS or Azure, maybe I'll say 1 out of 10. So if we don't have manpower or enough engineers who can manage the cloud, that's another challenge. Okay, but there's the opportunity for us that we can learn and get into that. The lack of visibility. Once you put in cloud, people worried about you don't have the visibility, what's happening. Okay. Then unplanned outages. So all these are the main challenges they have raised out. Sorry? Without plan, maybe it could happen in the cloud, on-prem or hybrid cloud. There could be some outages. So we'll talk about that, how they avoided with SDDC. There is one slide which they talk about how when you upgrade it, they call it hitless upgrade. When you do any upgrade or even some of the boxes bring down, it doesn't impact the entire operation. So they reduce the outages. When you plan any outages and in the entire cloud, it doesn't impact the services. No, it's on the cloud. You do in the live, but you have built-in capability that it auto heals. No downtime. Yeah, we'll talk about it. Okay, how it helps to do the reliability, high availability. We'll talk about that. So two different next steps, a different vision of the future. Today you have hybrid clouds. Then they're talking about on-prem. So in cloud networking, tomorrow will be seamless hybrid clouds. So you will integrate your on-prem and also you will have on cloud. You will have hybrid. So based on the business, you will have combination. Especially with IoT, you cannot put everything on cloud. Concept of IoT is making possible that you cannot say everything can be on cloud. You have to have something also on-prem because most of the data has to be stored, locally. That is another challenge they are going to face. That's why they talk about seamless hybrid cloud.